following right in the wake of the other one. There's another one. I can't see if I'm getting it or not. Three of them right in the same path. Here comes one.
Concepts for directly and deliberately manipulating Earth's climate system, collectively referred to as geoengineering, have been proposed as contingency responses to global warming.
Environment. And this is one of the first official references to geoengineering. They said a change in the radiation balance of the Earth and the opposite direction from the warming caused from greenhouse gases could be produced by raising the reflectivity or the albedo of the Earth, right? So this is the first kind of official reference to geoengineering. And over the decades that followed, some very outstanding scientists, both in the Soviet Union and the US, proposed in the scientific literature that we consider this as a fallback.
My name is Simon Nicholson. I'm director of the Global Environmental Politics program here in the School of International Service. And also co-direct a group called the Forum for Climate Engineering Assessment. And this is the third in our 4-forum speaker series looking at the politics of climate engineering. Before I introduce our speaker and our, what do we call you, Admiralty, our discussant, let me just say a little about the forum and to set up the talk by talking just a little bit about what climate engineering is for those who are new to the conversation. So the forum is an enterprise which has been around for a couple of years, and we're looking to try and build a more robust conversation around this thing called climate engineering. For those who don't know, climate engineering is an umbrella term for a set of imagined large-scale technological responses to climate change. And most folks talk about two different potential buckets of response, carbon dioxide removal to draw carbon out of the atmosphere and hold it in storage, or what's called solar radiation management or albedo modification to try and increase the reflectivity of some part of the planet's system to put solar radiation back into space before it can warm the atmosphere.
So what does all this mean? It means barring a change in behavior, that the very hard to think about climate intervention technologies become more possible, because we will put ourselves in a position where that may be the least bad option. I don't know if that's sort of related to the Hippocratic Oath or not, but it may not be do no harm. It may be, well, we think this is less harm.
Okay, so now we're engineers. How do we save the planet? Okay, plan A that the human species is working on right now is to do two things, to mitigate and adapt. Mitigate means stop putting so much greenhouse gases into the air. The other one is to adapt. Notice that the arrow goes in the opposite direction. We don't control temperature, we respond to it. So the other thing that we're doing is we're preparing for the future. People are moving away from the coast, we're building seawalls, we're preparing for storm surge, we're trying to build more resilient energy systems, we're trying to deal with resiliency in agricultural systems. A lot of funding is being spent around the world on adapting, preparing for the worst. Okay, so that's plan A. Now what happens if that's not enough? Here's where geoengineering comes in. Plan B has two parts. The first part is to literally pull carbon dioxide out of the atmosphere. The other scheme is to increase the albedo, right? So I can turn up the albedo, make the Earth shinier. And this is called solar radiation management. So remember those two terms. Okay. So there have been a number of schemes proposed for geoengineering, and I'm not going to go through all of them. I'm going to pick a few examples, but they're generally bent into two groups. One is solar radiation management, which is basically cutting back on the amount of incoming solar radiation, whether I'm using sunshades in space or doing things in the atmosphere, changing the Earth's surface. And the other option is pulling CO2 out of the atmosphere, CO2 removal, using a lot of different techniques. I'm going to talk about a few. So, method one for reducing the amount of sunlight hitting the Earth is called stratospheric aerosol injection. What does that mean? Well, scientists pay attention to what happens in the natural environment. And something they've known for a long time is when you have very large volcanoes, we see a drop in temperature around the world. Why does that happen? Well, very big volcanoes like Mount Pinatubo that erupted in the Philippines several times, but in 1991, it lofted so much stuff into the stratosphere in the form of aerosols, sulfur dioxide, that you actually get a haze. This dark layer here is an after photo. Here's a before photo looking at the atmosphere. Here's an after. So we're taking a lesson from Mother Nature. So the idea is, well, if Mother Nature can do that, why don't we? So there have been a variety of schemes proposed, ranging from zany to pretty low tech. And they all have to do with getting aerosols into the stratosphere and keeping them there for years and years and years. So for example, if we used existing technology, if we used aircraft, this would be the equivalent of taking a small airline and just saying, you do nothing but spray aerosols in the stratosphere for the next N decades. So think about how much that costs. Buy your own airline and do nothing but spray this stuff into the stratosphere. You know, seriously, what are the problems with these? So this is built on some work by Alan Robach, one of my colleagues, and also Mike McCracken, and I've tried to condense it to look at both the solar radiation management and carbon dioxide removal. And if we just look at the climate system, environmental systems, there are a lot of issues. One is it's known from looking at volcanic eruptions and this cooling effect that you get uneven heating, and you actually cause drought in some areas. So country A decides to do geoengineering, and they cause a drought in country B. You know, the missiles start flying. What happens if we stop it abruptly? If we can't get control of CO2 and we start, you know, injecting stuff in the stratosphere, it's costing us $10 billion a year, and we have an economic meltdown or a natural disaster or a volcano erupts and we can't fly airplanes for a while. What happens if that shield is removed quickly? We rapidly jump up in temperature. And the concern, even greater than that, is the fact of what we call instability in the system. If you whack a bell, it rings for a while. The concern of the climate system ringing like a bell and being unstable is a big concern. Climate models show this sort of stuff happens if you shut it off quickly. And there are a lot of other issues. We don't know what happens to ozone in some of these cases. We don't know what happens to cirrus clouds. If you make more cirrus clouds, you make things warmer. There have been studies, what I kind of call one-off studies. There was one that was done by the United Kingdom, the Royal Society a few years ago, where they tried to assess the relative affordability of some of these options versus the effectiveness. So ones up here in the right-hand quadrant would be considered optimal, but that raises a concern, right? If it's perceived to be cheap and effective, then in the words of Dr. Strangelove, it merely requires the will of trying this.